Hi guys, welcome to this video on prototype design pattern. Prototype design pattern is also a creational design pattern that enables us to create new objects from existing objects by cloning them or copying them instead of creating the new objects from scratch. Now, this is particularly useful when the object creation is expensive or complex. In this video, we'll see what is prototype design pattern with the help of an example, and then we will jump to the advantages, disadvantages, and when to use prototype design pattern and when not. We'll also see why use prototype design pattern, what is it that it offers, right? So grab your Xcode and let's get started. I will create a file here. I will mention the definition here quickly. Now here I've mentioned the definition, and we will see an example, and after that we'll come to a question of why use prototype design pattern. So I'll write an example here. So this is the class, which is a simple class with Apple. It has two stored property, price and count, of type integer, and a function which will set the price, and if there is no price set, or it's an optional parameter, so if there is no price has been given, then it will default give it 20, and an initializer to initialize the stored property. So what I will do is create an object Apple, and I will give it the price 22, count is going to be 4 3. So this is one object. Now if I want to create another object, red apple, then I will be making another object from scratch, giving the price and the count again. So what I'm doing here is creating a new object, and I'm creating it from scratch. What if there were more than 2 parameters? What if there were 10 parameters? Okay, so the thing is, all the parameter values would have been could have been same as the parameter values of the first object we created. In that case, it's really a repetitive thing that we are doing, that we are giving the values to all the properties once again, although it is same as the previous one. If there was a way to clone this or copy this object and then make the change in the required properties we want to give new value to, that would have been great, right? Now that is where the prototype design pattern comes in. We can take the first object as the prototype, copy this and create the second object, and then make changes to its property. So how is that possible? I will create a protocol here. Now here is the protocol fruit, which has the method clone. I will make this confirmed by the class apple. Now I will have to implement the requirement of the protocol, that is this clone. I will copy it and paste it here. Now what this method does is, instead of creating the new object, I can just use apple and call clone method in it. And what I'm expecting is, I want the clone of the apple object. So it has the values 22 and 3. What I will do here is create the object apple and give the values here. So when I say apple.clone, apple is the current type that I'm using here with the keyword self. So self is the keyword which is referring to the caller, that is also known as the current object. So here apple is the current object and I can access it using self, and after that I can access price of it and assign it to the parameter. Similarly, I will access count as well. So I'm accessing the count property of the current object, which is apple, and I'm taking the values of the properties of the apple here and just assigning it to the parameters and making a new object. And what I will do is I will just return it. So what it is going to do is, it is just creating a new object which is the clone of the apple. Now you would notice it is returning the value of type fruit, but not apple. So fruit is the superior type. So when we catch this value here, we have to downcast it first before we assign it to the red apple. So here I will downcast it to apple. So what we're doing is the fruit is the superior type and apple is the subtype, and we are sending a fruit that is the superior type here, and here we are downcasting it to the subclass or the subtype, and then I will assign it to red apple. And what I can do is access the properties of the red apple, that is price, and make the change to it like this. Now I will print price of both the objects, the existing and the cloned one. So I will say apple dot price, red apple dot price. Let's run this, and we get 23 and 22 and 23. So which is the values of the original and the cloned. I will rename it to cloned apple. Use it here and here. Let's run it again. Now just to go through this example once again, what we have learned is when we created the original apple object, we initialized all the properties with the values. Now if I want to create another object with the same values, then it's better to clone the existing object, right? But if we do not use this prototype pattern, then we have to create the object from scratch and give all the same values to the properties of while we are creating the new object. But when we clone it, we can just clone, and when we write the clone function here, we create the new object and we take all the values of the original object. Now here the self refers to the caller, that is the current object in the scope, which is apple here, and then it uses the price and the count values and create a new object in the clone method. Once that is done, we will downcast it to apple type, which is the subtype. So apple is the subtype and fruit is the supertype. We are returning the supertype here. So the apple is the object which is appearing as the object of the supertype, and then we downcast it. Now here I'm force downcasting using the exclamation mark because I'm sure that what I'm cloning is the object of apple only. So for sure the subtype is going to be of apple. Now after that I can make change to the properties. So I can change the property price to new property, and if I want to make change to count, I can do that as well. And that's it. Now let's move on and take a look at one more example. Now this is the second example that we will see. Now that we have some understanding of prototype design pattern, we will understand a new concept that is used in prototype design pattern, that is the self versus the self keyword. The difference between these two keywords is something we will learn. Now you will notice the first letter S is small and big. So there is a difference in these two keywords. So here I have created the protocol clonable, which has the method clone, and it is returning the type self. So because in the previous protocol we were returning fruit because we knew that it is going to be implemented by class apple. So we will return an object apple here, and it is kind of a fruit. So rather, instead of saying self, I would say the concrete type fruit because it will make more sense here. But we should go with this structure where we actually make it more compatible with any of the class that will implement it. So I don't really mention here sensible name, rather I would just say self. That will refer to the type which will conform to this protocol. Now this is the class employee which is conforming to the protocol clonable. Let's go through this employee class. What do we have in it? So this class has three properties: name, role, and department of type string. it has one required initializer, and here we are implementing the requirement of the protocol, that is the clone method. Now what we do in the clone method is create the object of the employee. Now the way we are creating it, we will go through it in a moment, but you would notice here we are returning self with the capital S. Now this is referring to the type employee here. Let's come down here and see the usage, that is two objects I've created. One is named original employee and one is the cloned employee. In the original employee, I'm creating the object from scratch, giving the name, role, and department some string values. And when it comes to cloning this original employee object, I would say original employee dot clone. So it will fire this method. And what will happen is this original employee is the current object here, which is the self with the small s. And when we are done with the creation of the cloned object here, we are returning the object of type class, that is employee, which is capital S self. So small s referred to the current object, which is the caller, and capital S referred to the type itself, that is the employee. So I've mentioned it here in the form of a question as well, difference between self and self. Now the small self, it refers to the current instance object, or I will say for clarity, example caller, which is here original employee. And capital S self refers to the type itself, ensuring type safety and clarity. Now this is really just to keep the difference between the caller type and the type we are returning. Now here let's focus on the return, how we are creating or cloning the object, right? So since the current object is original employee, we um, we have self with a small s and just accessing name, role, and department values of it and just giving it to the parameter of the initializer. So initializer is going to create a new object for us. Now how to access the initializer which is present inside the employee, right? So we will actually have this original employee self, to which we will put inside this method called type of. So of is the parameter to which we will just assign, and it will give us the type, that is employee, and then we can go ahead and access I90, and that's all what we are doing here. And that's it, we are cloning the object. Once we have done cloning the object, we can modify any of the, so only one property is has a change, that is the clone employee role property. We are changing it to from engineer to team lead, and that's it. Now here I'm returning original object property values and cloned object property values. Let's run this. Before that, I will comment our previous example here. Let's just comment print. Let's run it. It gives us the values. Alice engineer development, Alice team lead development. Now let's talk about why use prototype design pattern. The first is efficient object creation. So we can cloning an existing object is often more efficient than constructing it from scratch, and especially when object has many properties or requires heavy computation. Next is dynamic object configuration, allows runtime determination of the type and configuring of the object to be cloned. So here we are runtime, we are determining the object of the type and then creating the new object and dynamically giving the values here like this, and avoid subclassing. Reduces the need to create subclasses for each configuration, as cloning allows for flexible modification. This is something we will see with the help of example when we will talk about the advantages in a moment. Anyways, the next is we're talking about the advantages. So I will write it here. Now, the very first advantage is efficient object creation. That is, reduces the overhead of creating objects from scratch. We have just talked about it. If the construction process is resource intensive, second is simplifies object hierarchy. Now we will take a look at the second one with the help of an example. First, let's take a read on this. Avoids the need to create large number of subclasses by allowing dynamic configuration of cloning. What do we mean by that is, now let's see an example of it. Here I will write an example. Here we have a class shape and we have two other classes, red circle, blue rectangle, and which is inheriting the class shape. Now we are creating these classes red circle and blue rectangle is because first we will see that the shape class has two properties, color, border width, and an initializer for it. And the red circle, we are creating this class because we want red color circle. So we have a radius property which is of the red circle class and the initializer for it. In the initializer, we are using the super keyword to make a call to the super class initializer, and we are passing the color red to it. And the border width also has a default value too. Now you will notice to create a red circle, we had to create a subclass and then we had to assign the property red to it. It's just like if I want to create another variation of shape like blue rectangle. So I will create another class and make it a subclass of shape so that I will inherit the color and border width properties. And then I will have an initializer where I will initialize the properties of the blue rectangle itself and also the properties of the super initializer. So I will assign the values to the properties which is of blue rectangle, and then I will access the super initializer and give it a default value blue because this is a class blue rectangle and a border with some default value. So you will notice blue and red here is the value that we are giving after creating this subclass. Now suppose I want to create another variation of the shape, let's say a blue circle. Now without the prototype pattern, if you want to create a variation of the shape, then we will have to create a class for it and a subclass for it and do the write the code again, the repetitive code, and write the configuration again. And that is what we can avoid. For example, here we have the class red circle. If I want a shape variation, let's say yellow circle, then I will have to create a class for it and make it conform to shape and then have some property radius and an initializer for it. And inside that I will access the super.init and give it yellow. And that is how I will have to create another variation of shape circle. And that actually is a problem called as the subclass explosion. And how to handle this is basically to use the prototype design pattern. What it does is it simplifies the object hierarchy then. Let's see how we do that. So without prototype in use, without prototype. And now I will mention a short description here first. So I've written here what we have just discussed. This approach forces you to create a new subclass, red circle, blue rectangle, etc. for every variation of shapes. If you need a green rectangle or yellow circle tomorrow, you will need to have the additional subclasses. This leads to subclass explosion and increases maintenance overhead. If we use the prototype design pattern, when we use the prototype design pattern, I will comment this code because we will be getting redeclaration error. Now you will see, okay, I will have to comment the above protocol as well. So I would rather comment the whole code here and this protocol. And also, okay, this is fine. Now here we have the protocol clonable, and we have the class shape, inside which we have one required initializer, which will initialize the stored properties of shape. And we have the method clone, which is the implementation of the requirement of protocol clonable here. Now that we understand protocol and shape here, now if you want to create the variation of shape, you can just create the class circle, and inside that we are having the clone method overridden, that is inside shape also present, which is here. Now why do we have a clone method implemented by shape and overridden by circle? We will see that in a moment. Let's first understand the two more things that we have inside the class circle, which is the two initializer. So first initializer is there to initialize the radius property of the circle. We are also asking for color and border width and assigning it to the super INIT. In the required initializer, we are giving a default value to the radius, which is the property of circle, and just using the super keyword and initializing the super object with the color and border width we are asking in the parameter. Now that we understand these two initializers, we will come to the overriding clone method, but let's go here and understand the object creation first. So we have created the original circle, and we have given the property radius a value, and we have created a red circle. So here we have the original circle, which is a red circle, we can also call it. Now, what I'm doing is I want to create a yellow circle or blue circle. So I don't have to create a new subclass yellow circle. Rather, I can just clone the original circle and make a change in it by accessing the color property here. Now, to be able to do this, we have to clone the the current object that we are passing here, and we will see that how we do it and why. Because to do it, we have clone method implemented by class shape also, and our subclass circle also. And why do we have two initializers here? We will understand that. But just to be clear with the prototype, when we were not using prototype pattern, we had to create subclass for every variation of shape, like yellow circle, blue circle, red circle. So we did create red circle, but we were not able to clone red circle and make a yellow circle. I had to create a class yellow circle, and then I was able to create the object of yellow circle, inside which what we were doing is accessing the super.init and giving it yellow color, right? Now going back. Now here when I clone, what we're doing is this 3 lines of code is running, and we will understand this very clearly first. So I'm creating a let constant cloned here. What I'm doing is using the super keyword to call the clone and get the object of the shape. That is, in the shape class, we have the clone implemented, which is going to understand the type of the small type of self with the small s, that is the current object. So in this case, it is going to be the caller, which is original circle. So when we say original circle dot clone, it comes here, and we don't have to write like self dot super dot clone to send this original circle to here. We can just do super dot clone, and it will identify the caller type here. What it will do is take the color and border width values and clone the object of shape and give it here. And we will downcast it to circle by using the as operator. And once the downcasting is done, we have the cloned object ready. What else we are doing? in this method in the next line is we are accessing the radius property of the cloned object and giving it the radius value of the current object, that is original circle. So we have the original circle, which is this. It has one property, radius. We have given the values of color and border width in here, but we did not give value of radius to our cloned object. And that's what we are doing here. Once we are done with the second line, in the third line, we take the cloned object and downcast it to the type itself, that is the self with capital S. Why do we do that? So when we in the first step say super dot clone, it will give us the type shape. So we are downcasting shape into circle. Once we receive the circle, we make the radius value same as what we have in the original object. Then we take the cloned and we downcast it to the type itself, that is the circle, because that is what we need to return here. If we do not do it, then it will be of type shape, although we have downcasted it to circle. But and then the cloned, we have to downcast it to the type self, because we are sending self here, not circle. If we do not write it, we will see an error which says cannot convert return expression of type circle. We have downcasted the shape into circle, but we cannot return circle. We have to write the type self here. So we have to downcast it to the type self. So it says convert, cannot convert return expression of type circle to return type self. And that's why we will do self. And that is how we are cloning. Now, this may look a bit complicated, but what exactly we are doing is this original circle, we have three properties. We want to make sure that the new object we are creating should have the same values, 5 red and 2 in it. How do we do that? In this method, we are doing that. In the very first, we are making the shape object using the clone method of the shape. When it is returned, we have assigned color and border width properties of our new object a value taken from the current object original circle. All that is left is the clone object do not have value inside the radius property. So that is what we did in this second line. And in the third line, we have to do downcasting to the type self with capital S, which is referring to the circle, because we are returning here self. And that is it. After the cloning is done, we get the cloned circle, and now we can make changes to the color. And that is how we do not need to subclass for creating a yellow circle. We have created a red circle, called it original circle. Then we have created the clone circle, which is the blue circle. But we never had to do any subclassing here. So we can avoid the subclass explosion problem using this prototype design pattern. Then we can make change to radius, color, any of the properties. And here I'm printing the color and radius of original circle and also of cloned circle. We can run it. Let's first go up and comment any code if there is any. Okay, let's run this. And it says original circle red, radius 5, clone circle blue, radius 10. Now there is one warning we are seeing here, that is forced cast from self with capital S to circle always succeed. Did you mean to use as question mark? So I am doing this force casting, force down casting, because I know the type that super dot clone is going to give me is shape, which is a superior type, and I'm going to downcast it to circle because I know it is possible, and that's why I'm force downcasting it rather than doing it optional downcasting. I'm doing forced downcasting. And I hope you understand what do we mean by the simple object hierarchy. You don't have to create subclasses, create large hierarchy. Rather, you should just use the prototype pattern and take advantage of the cloning as much as possible to avoid the explosion, the subclass explosion. Now it says avoid the need to create large number of subclasses by allowing dynamic configuration of cloning. So what do we mean by dynamic configuration of cloning? Nothing. Just dynamically we are assigning the values to our cloned object like this. We are dynamically assigning the value radius to our cloned object property radius. And in here we are dynamically assigning the value color and border width to our cloned object shape. And that's it. Now again, overriding is used because it's a capability of shape, and that's why we are doing it. We are There is no need for us to write clonable here for the circle because it is a subclass of shape only, and shape is conforming to the protocol clonable. Circle is also going to be conforming to the protocol, and we can just override it. And that's it. Let's talk about the next one, the runtime object customize. Objects can be cloned and then customized at runtime based on a specific requirement without altering the original object. Now, we are talking about these two properties we have changed of the clone object. The original object, original circle here, doesn't need to know anything about the clone circle here, and we can make changes to our cloned circle properties, and there is no effect on the original circle for whatever we do with the clone circle. Now going back, so I've written here without altering the original object, we can make changes to our cloned object. Also, I will mention a short note here in the end. Without and with prototype, what is the difference? So I've written here why prototype simplifies the hierarchy. Without prototype, subclasses explode for every variation of shape. With prototype, you reuse the base class and dynamically configure the objects by cloning. Let's come back to the fourth point. I will mention with prototype a short note here. I've mentioned a note here, using the prototype pattern, you can create a base shape class and clone existing shape to dynamically configure them, avoiding the need for multiple subclasses. So the fourth one is the decoupling. Decouples the client code from classes used to instantiate object. The client does not need to know how circle objects are created. Instead, the client clones a shape object and customize it as needed. So client would be the original circle, which is this, and our cloned object is the one which we are creating using the shape and then customizing it as we need, that is downcasting it to circle and assigning some values to the properties of the circle and then returning the clone, and that's it. Now let's talk about the disadvantages of prototype. Here I've written disadvantages of prototype. Starting with the very first, that is the cloning complexity. So cloning objects can be complex when dealing with deep copying, especially if the object contains reference to other objects. What do I mean by this is when we create the clone, we are creating a new object, right? So what we're doing is really creating a deep copy of the original object. Now, what if instead of deep copy, there is a shallow copy? So first, we will understand the difference between shallow copy and deep copy in just a brief so that we are good to go ahead. Now, before we understand the difference between shallow copy and deep copy, I will just write one step cloning complexity. The problem is when an object contains references to other objects, cloning becomes complex because you need to decide whether to perform a shallow copy or deep copy. Shallow copy only duplicates the reference while a deep copy duplicates the actual object. For example, if we have the original circle, the address of original circle is, let's say, this. So when we do shallow copying, it only takes the reference, that is the address, and put inside here, which is the clone circle. So this is cloned and this is original. This is called shallow copying. And in the deep copying, what happens is it copies the values inside the reference. So it goes to the reference address, goes inside and take these values, which is 5 red and 2 of the original circle, creates a new object using these three values, and that is what we are doing in the clone method, and gives it to the clone circle. So in the clone method, we are creating a new object, right? So this is called deep copying. We just keep the values here. So what is the difference between shallow and deep copying is if you make a change in the original object property values, that is basically going to reflect in the cloned object, because in cloned object we do not have any new property values, just a reference to which we go and fetch. In the deep copying, we have the new properties values, and if you make any change to the original circle, it does not affect the cloned object or the cloned object, that is the cloned circle. And that is what deep copying is all about. These two objects are going to be independent, and the problem is if we have the shallow copying in our clone method, when we write our clone method, if we are doing shallow copy, then it's a problem. And we will understand this with the help of an example. I will write here. So I've written here shallow copy. We have a class address and a person, and we are creating the person object. First is original person and clone person. And we will see the content of the address and the content of the person class in a moment. But before that, let's take a look at the usage. That is, when we are creating the original person, we create the object giving values to name, address, the two properties of the person. Now name is of type string, so we give it the string Alice, and address is of type address, which is a class inside which we have a initializer and a property city, and we are giving the object of address here. So we created the object of address and given a value to the city property, that is New York 1. So when we create the copy of this or clone of this original person object, we have to decide whether to do a shallow copy or a deep copy. So we have seen previously deep copy examples. In here we will see how to do shallow copy. So copy is the method we are calling. Now this is the method same as cloning, but here we are doing shallow cloning or shallow copying, we can call it. It's the same thing. Now, now here I've written it copy. We can write it clone as well. Not a problem. So here what we are doing is we are making the person class from to protocol NS copying so that we can implement the copying mechanism code. So the person is confirming to protocol NS copying here. We are doing it so that to make the shallow copy code work, we have to make the person confirm to the protocol NS copying. And nothing much there. Inside this, we have a variable zone, which is of type NS zone optional. It is going to be nil. We are not giving any values to that parameter at the moment, and returning any, which is just basically going to return a person object inside which we are using self, which is referring to the original person, the current object in the scope, and then accessing the values to it and trying to create the copy of it. So here we are doing shallow copy of the address. So if you will see, we say self dot address. So what it gives us is this address, and it gives us the reference of this object which we created for the original person object. And we are assigning that reference to our cloned object person here, which we will receive in the clone person. Now, if we make any change to the address of the original person, it will reflect in the address of the clone person. So that is the next thing we did. We are accessing the clone person dot address dot city, and from New York we are changing it to Los Angeles one. And then we are checking the values of address of original and address of cloned object. Original person address city, original person address, clone person address city. Now, unexpected is this thing. The original object will, of course, will change because it's a shallow copy. Let's run this and see this in action. And it gives us the original address is Los Angeles 1. Cloned address is Los Angeles 1. So this is a problem with the prototype pattern. You have to make sure the copying is happening or the cloning is happening in a deep copy way, not shallow copying is happening there. And that is the problem with prototype design pattern, that you have to make sure that the copying or cloning you're doing should have deep cloning in it or deep copying in it. If there is a shallow copying, that you are just copying the address and making a change to that same address using the cloned person or cloned object. I will also mention a short explanation what we have just seen here. So I've written the address property is shallow copied. So both original person and clone person share the same address instance. Modifying the address of the clone affects the original object, leading to unintended behavior. And this is not we want. This behavior is something that we have to be aware about. And now we can move on to the next disadvantage. So we have just seen cloning complexity. Next is unexpected behavior. If the original object changes, the cloned object might also be affected in cases of shallow copying. And we have just seen that, but there is one more thing to notice. So I will rather give one example for it down here. We have a class settings here. We have a class settings here, which has a one store property theme, an initializer for it, and a clone method is here. It is returning the settings, and we are just creating the clone of the current object which we will receive here. So here we have the original settings and the theme is dark. In the clone setting, we are saying original setting dot clone, and it will give us the setting with the dark value. We are making the change in the original setting here like this. We are making it light. Original object is changed after cloning. Now the cloning is done and we are printing the theme of both. So the first is dark. The original setting has dark value, and then we change it to light. So it will print us light. And the clone object is unchanged. So it will give us dark, which is expected, right? The values are expected. This is what we are expecting. But one thing to learn is if you rely on the cloned object retaining the original state at the time of cloning, changes to the original object after cloning may lead to inconsistencies when working with clone. What do I mean by this is, so generally when we say cloning, right? So cloning must have the same state. It should be really a clone all the time. But that is not the case. If you want the clone setting to be at the same state, so the original setting was the very first state was the value was dark. We changed it to light, and the second state of original setting object was light. Now, if you want this clone setting also to follow and have the same state and retain the same state as that of original state, then that is not expected because these two are going to be independent. Now, when we say the term cloning, generally people thinks that it should be the clone all the time. No, after you are done cloning the object, those two objects are going to be independent. And if you do shallow copying, it's not independent objects. If you do deep copying, then it's independent object, and you cannot expect for them to stay cloned or appear same all the time. Now let's move on to the next one. That is, so the unexpected behavior is do not expect the cloned object to stay cloned all the time. After the cloning is done and the cloning is done in a deep fashion, in a deep copying is done, then they are going to be independent objects. And if the shallow copying is there, then it will not be an independent object. The next is inconsistent states. Modifying a clone can lead to inconsistent state if not handled carefully. Inconsistent states, what do I mean by this is it's the same as what we were talking about in the previous point. I will write an example for it. So we have the class document here has two properties, title and content. We have an initializer for it and a clone method which is returning the document. So we will take self.title and self.content. That is the current object. So we created the original document with some values, and the original document is going to be the self. That is the current object in the scope, taking their values and creating the clone. Once the cloning is done, we have the clone and original object present. Now, the cloned object, we go to those two properties, change in it. So title is changed from report to summary, and we do not have any content for it, so we left it empty. So when we leave the values empty, this may return in some runtime error or logical inconsistency, and that is going to be a big problem. So whenever we do the modification, we have to be aware that the modification should make sense, and we cannot leave empty sometimes. I will mention this here. So here is a summary. In the cloning complexity, we have seen that the object with references to other objects need careful handling, and we are referring to shallow copy in that case. We saw the difference between deep copying and shallow copying and how the shallow copying affects the copying. Unexpected behavior changes to the original object after cloning may cause the clone to have to behave differently than expected. And that is one of the agenda. Of course, after cloning, you can do anything with the cloned object because if you do deep copying, it's really a separate object after that. Inconsistent states. Modifying the cloned object without understanding its constraints can lead to invalid or inconsistent states. And that is it. Now let's talk about when to use prototype pattern and when not to use. So when it comes to expensive object creation, then we should definitely go with prototype design pattern. When creating an object from scratch is computationally expensive or time consuming, rather make a clone of it and make change to the properties. Similar objects, when you need multiple similar objects with slight variation, let's say there are 10 variables and you want to have a new object created from scratch, or you're creating a new object from scratch and only one parameter value is different from the object you created just before, then rather just clone it and then make the change into that one property. Configuration, when the type and structure of the object to be created can only be determined at runtime. So when we write the clone method, when we use the current object property values to create the cloned object, that is called dynamically aligning or dynamically giving the values. That is called dynamically giving the values. And we have seen avoiding subclass explosion. We don't have to create subclass for every variation of the super type. We can just create the clone. We can take the advantage of prototype pattern and use the clone method and define it, write the code in such a way that we take advantage of the clone method. To prevent creating too many subclasses for different configuration, instead of creating a lot of subclasses for every variation, we take advantage of the clone method and write it very well. And when not to use prototype design pattern, simple objects. Now, simple object creation, when creating simple object is simple. When creating object is simple and does not involve significant computational or structural complexity, then do not use it. Second is deep copying complexity. We learned about that. When the object involves deep copying with multiple dependencies, making cloning cumbersome. So when we are doing deep copying and there is a lot of dependencies, when things are getting too complex, then that's the borderline. We just draw a line there and then, because The moment things becomes complex for your pattern when you're applying, you can stop using it then and there. You can give it a thought, extra thought, definitely, but there is a degree of complexity up to which we are good to go and implement the design pattern. That is something that comes with practice. You would know in production level code when exactly we really go with prototype design pattern. You would see a lot of different cases using prototype design pattern, and you would develop an understanding and eye for when exactly we should go with prototype design pattern. When things become way too complex, you have to give it a thought and take a decision whether to move forward, implement the prototype pattern or not. Immutable objects. When working with immutable objects, cloning is unnecessary as the state of the object cannot change. So if the original object that you have created is immutable, let's say it's a structure, and you do not have any method marked as mutable, there's no need for us to create a clone of it because um, it cannot, the properties cannot change. So there is no point of creating or implementing the prototype pattern. Next is object without a structure. If there is no structure to the object creation process in itself, then we have to fix that first and then go forward implement the prototype design pattern. What it says, if the object do not have a clear structure or interface to support cloning, the prototype pattern becomes impractical. So what it means is we should always create a protocol inside that give a requirement, the clone as the requirement, and then make it conform by the classes and make the class implement the requirements of the protocol. If that seems difficult, impractical, that is a borderline again. And that is it. That is all that we need to learn when it comes to prototype design pattern. I hope you find this video informative, and I will see you.